Hello, everybody. Mr. Biankowski here. This is the 1.1 summary. Excuse me. So, geography is a science because as we talked about yesterday, it's got aspects of the social science, but then also the physical sciences. So, social science element, the human elements of geography, culture, economy, politics, and then the hard science like meteorology, climatology, geology, all those things. So it's an intersection of studying planet Earth with a lot of scientific instruments and scientific principles, but then also the social sciences, understanding how humans inhabit the planet. So it's a combination, kind of a crossover of those two things. Definition of geography is here. It's a spatial perspective, so it looks at where things happen. Everything happens somewhere. Those locations are important. Sometimes they affect why things happen in those places. And so geographers are looking at patterns. Are there similarities in places? Distribution, how are things arranged? And diffusion, where are things moving to, and tracking those movements. So geography covers all of those things. If we skip over those things, the ancient Greek society is what contributed to the growth of geography as a discipline. So the fact that you're taking this class in school, you can thank this guy here, Eratosthenes, a Greek scholar, coined the term geography. Geo means earth, graph to write, so literally to write about the earth. While historians are focused on when things happen and the chronology, the sequence of events, geographers are looking at where things occurred and why it occurred in those places. So here's the guy. There's this picture. I don't know if that's what he actually looked like, but he's got a really big head that kind of looks like planet Earth. But he was really, really smart. He was a Renaissance man before the Renaissance. He calculated the distance from the Earth to the Sun, the circumference of the Earth, came up with an idea of a grid system, latitude and longitude. He was very intelligent and had a big contribution to our interest in geography. There's a little video clip you can watch here. Explains the largest company, one of the largest companies in the world is essentially a geography company, Google. They know how to find information in the biggest library in the world, the internet. And so by navigating and trying to connect you with the information you're looking for, they realize that it's the same with on the planet. So Google Earth and Google Maps we use every day. And so they realize the need to be able to find things in the world. And so that's really what their company is based on. An example of that is saving herds of elephants in the African continent. They realized that due to desertification and environmental conditions, their migration patterns were much larger than they had ordinarily been. And they realized also that they were getting into places where people were also suffering those effects of desertification and the growing of the desert, and their livelihood, farming and herding, were being hit. And so they were resorting to poaching in order to make a living. And so they realized if they'd help those communities, they also save the elephant herds. And so it was a very practical way for geography and geographic information to help do some good in the world. So geography focuses on places. Sometimes we lump individual places together and put them into regions. These regions and places are not completely separate; they're interrelated, and we look at that in terms of this idea of scale, the relationship between the portion of the Earth being studied and the Earth as a whole. And so we're constantly comparing what it's like in one place and relative to other places. These are just some pictures showing the use of geography. This was during Hurricane Katrina. There were maps of neighborhoods and rescue operations and how do we prevent water flow from entering places where people are living. So we learned a lot about geography in these disaster type of situations. California fires, same thing. This is kind of an invented term, this idea of globalization. So everybody's familiar with globalization, the movement of things from one location and kind of replicating that idea like at McDonald's in other parts of the world. But localization is something that a lot of companies have learned, that you can't just have the same type of uh, culture and system and think that that's going to fly everywhere in the world. So you got to adapt a little bit to be more local. So sushi on the menu at a McDonald's in Japan might be an example of that. There's all kinds of ways in which geographic information is used. One of those ways is to forecast demographic change. And so the Carver County government came up with this land use map to show how land might be used and changed in its use as population grows in the future. So that's what this map takes a look at. You can access the map right there. Think about how many of you are really good with directions. You know, I'm somebody that just kind of gets it, but there's a lot of people that don't. But one reason to study geography is it improves your mental map. And when you have a pretty good sense of where things are located, it increases the amount of activity space, the amount of ground that you cover, the amount of places that seem reachable and that you can access. So when you do that, it also increases your opportunities. So one way to increase your opportunities is to increase your knowledge of the world and those, even on a small scale, you know, your own neighborhood. But again, it gives you more and more opportunities available. The more opportunities are available, the higher standard of living and all of the things that we think about of a very advanced society kind of come into reach. A couple of different kinds of maps, reference maps versus thematic maps. There's a couple of slides here that tell you about the difference there, and then a number of examples of these. So this might be a reference map, but thematic maps can use a number of different communication devices. So this one is graduated circles to show population distribution in the state of California. So much of the state is relatively rural, even though it has the largest population of any U.S. state. You can use a dot distribution map. This is an isoline map, which shows population kind of maybe a little more specifically, kind of like a weather map might do. And this one is a choropleth map. So we have easy divisions. California is divided up into counties, and then you can color those counties, color code them relative to how much their population is in that county. And so you can use that for comparative purposes. Sorry, I'm going through this pretty quickly. There's some questions for you to answer there, but you can do that on your own. You should know how GPS works. We use it every day, use it for directions and other very simple things, but there's a video here that explains it. You don't need to memorize exactly how it works, but I think it's good for us to know how it's measured and how our device gets that signal. And then there's all kinds of other uses. You know, we put chips in pets and maybe in the future in people. But a lot of athletes, we use these as well to determine conditioning and get some biometric information. So lots of uses there. GIS is Geographic Information System. This is what's called layers in Google Earth. So if you go to Google Earth and you look at the layers available, it's all this different types of information, like if you want to know restaurants or concert venues or where schools are located or hospitals. You have all these layers of information, and you can put as many of those layers on the map, or you can take them off the map. So Google Earth gives you the flexibility to create any kind of map you want based on the information you're looking for. So there's some videos and explanation of examples of the uses of those things in those other slides. Remote sensing or long distance photographs, they sense healthy vegetation based on the radiation, and this is a way to determine the health of the global environment. And there, again, many uses for those things. You should be familiar with scale. So map scale is how much of the map is going to be shown, but it's also important in looking at data. So if you look at, for example, deaths from cancer per 100,000 people. So let's say you're working for the CDC. Your goal is to reduce the death rates of cancer. One of the first things you'll want to find is where are the highest death rates? So where should we concentrate our efforts? And so if you look at just this map at this scale by state, you would see in the highest category, there's a pattern, the southern U.S. states. So there must be something about the culture or food or anything that contribute to cancer in these areas. But if you look at areas outside of the South, some of those areas in the Washington and Baltimore metropolitan area are actually higher than many of these southern states. And if you look by zip code in other parts, you can find big differences even among zip code. So you've got to look at things in conjunction with each other and at different same information at different scales in order to get a better picture of what things look like and to make better decisions. Let's see. And then every map is a projection. You got a spherical Earth, so you can't carry around a globe. You want to look at it on a flat screen, but anytime you translate that or project the spherical Earth onto a flat surface, there's going to be distortion. And anytime you correct for one of these types of distortion, you're going to make one of the other ones worse. So that's one of the problems we have of trying to communicate geographic information. You should know latitude and longitude, so the Earth grid here, the parallels and meridians, and how those work. A lot of times, rather than using north and south or west and east, they use positive numbers, negative numbers, depending on where it falls on the number line. The x-axis is the 0 degrees, the equator. The y-axis is the prime meridian right here, and then negative and positive, positive and negative. So you should be familiar with how to calculate locations and latitude and longitude coordinates. There's some examples there. Okay, that's it for today. Hopefully that helps you understand a few of those items if you had trouble getting it on your own, and have a good day.